Today, looking at rational expressions and combining two or more of those so that we have just one rational expression for our final answer. Remember, expressions can be things with pluses or minuses. Equations are when we have the equal sign and we have things written on both sides of the equal sign. So rational expressions means that they have a ratio in them, and so they look like a fraction. So a rational expression, two or more things that look like fractions, but with a bunch of letters in them. Remember, if we have an equation, that's what I was just saying, that's when we have something plus or minus something else. And the important part is that the equation says equals something on the other side. That's when we can clear fractions. We can multiply everything on the left and everything on the right by the LCD. We cannot do that if we only have one side of the equal sign. That's when we have an expression. So that's when we just have the something plus or minus something, maybe some more plus or minuses, but no equals something on the other side. That's when we write it with a common denominator. We can't multiply by the LCD to get rid of denominators. We're stuck with the denominators. So the second one is what we are doing today. So usually when we are combining terms, when we are simplifying the sum or difference of rational expressions, the directions will say add. That means write as one fraction. So start by getting a common denominator. So one fraction has a denominator of x, the other one has a denominator of x plus a. So we know that we need the common denominator to be x times x plus a when we're finished. Now, you may not show your work this way. I see this every single year. You may not say, oh, I need to multiply by x times x plus a. That's what we do when we have an equals on the other side. Even if you're thinking through the right steps, this is incorrect work, and I'll count off for it, because that's not what you're doing. You change it when you multiply an expression by one thing. It's equivalent if you have two sides of an equation to multiply by one thing. So what you need to do to show your work on this one is you need to fix each fraction separately. This one needs a denominator of x times x plus a. That means you multiply numerator and denominator by x plus a. You must write it both places, numerator and denominator. Don't be lazy and try to write it once. Similarly, this one needs to be x times x plus a. If you just do that, it's wrong. You're multiplying numerator and denominator by the same thing. You're multiplying each fraction by 1. Now we can multiply and combine any like terms we may have. So 4x plus 4a plus 6x, and who wants to tell me what we can combine to get our final answer? Hello, good morning. What can we combine? What are our like terms in that numerator? Layden? So we have 10x plus 4a over x times x plus a. And we always want to think, is there a GCF or anything else I could factor numerator and denominator? There is a GCF in the numerator of 2. But does that give me anything that I can cancel? So we at least have to think that. And in this case, I would accept either answer because factoring does not give anything that can cancel. Does that make sense? Okay, add. So once again, we need to get a common denominator for everything. This one is starting out as over 1. Who can tell me what the common denominator needs to be for my final answer? Lucas? Perfect. And I would leave it factored because that will let us see if there's anything we can cancel. There's no point in multiplying it out. This one has the m plus 4, so it is missing the m squared. Because that had a plus in it, I've got to put parentheses around it. Same thing for the numerator. Any numerators or denominators with pluses or minuses, put parentheses around them and distribute. The last one, we've got the m squared, but we need the m plus 4. The middle one, we need everything. We need the m squared, and we need the m plus 4. And again, we write it both places. Jonas, would you distribute my first numerator for me, please? Perfect. When you do this one, what I would do is say the 5 times the m squared is one term, and then let's distribute that all at once instead of trying to do the m squared times the m plus 4 and then all of that times 5. We can go ahead and take 5m squared all at once. John, can you do that distributing for me? Sounds good to me. And then for our last one, we need to distribute the 2. And what do we get there, Anna? Now we just need to look at that and see if there are any like terms that we can combine. What about my m cubes? That's my biggest power. Noah, do I have any I can put together? So how many m cubes do I end up with? So if we take these two, we have 6m cubed. And what about the m squares, Khadijah? So plus 23m squared. Do I have any other like terms? So we'll take the plus 2m plus 8. Are there any GCFs in that long numerator there? Anybody see a GCF? So we're done. Final answer. And let's do one more. Now, this one is a little bit tricky. Second denominator is pretty easy to tell what's going on. It's factored. First denominator has a z squared in it. And anytime you have a denominator or a parentheses with a z squared or a z cubed, you want to see if you can factor it. Can anybody see a way to factor z squared plus 5z plus 4? Given the factoring things that we reviewed last week. Chloe? So z plus 1 and z plus 4, thumbs up, thumbs down. Does that work? So that means our common denominator needs a z plus 1 and a z plus 4 in it. And then it has everything from the first denominator. It needs a z, which I don't have yet, so I need a z in that. It needs a z plus 4, but I already have that. So are we good with that's the common denominator? So then we look for what each part is missing. Parentheses around this because it had a plus or a minus sign in it. What's my first denominator missing? It's missing a z, so I need to multiply this one by z over z. Lucy, what's my second denominator missing? A z plus 1. So first we're going to distribute the first numerator, and we have z squared plus 3z. Now we have to be a little bit careful. We have a minus right here. That also has to be part of what we distribute. So I'm going to change this to a plus a negative 1 times this, so that I can distribute the minus sign and the 1 all at the same time and get a minus z and a minus 1. So final answer, z squared plus 2z minus 1 over z times z plus 1 and z plus 4. That numerator has a z squared in it, so I need to think, can it be factored? Two things that multiply to be negative 1. My only choice would be 1 and negative 1. Do those add to make 2? So can't factor it. So this is what we have. Questions from anybody on combining rational expressions or adding rational expressions together?